Hello everyone, myself Eklavya.
And myself, Shivam Kumar.
We are students at NMIMS SHIRPUR pursuing BTech in Computer Science Engineering with Data Science. You ever wondered how objects and program are created and how they get their initial values and how different classes in a program are connected and able to reuse code efficiently? These two important ideas are explained by the concepts of constructors and inheritance in Java. Today, I will be explaining these concepts in a clear and simple way along with examples and diagrams so that we can understand not just the theory but also how they are used in a real programming. So let's get started. Constructors play a key role in how objects are created and initialized. Let's begin by understanding what exactly a constructor is. A constructor is a special method in Java that is used to initialize an object. Whenever we create an object of a class, the constructor is automatically invoked. One important thing to remember is that the constructor has the same name as the class and it does not have any return type, not even void. In simple terms, we can think of a constructor as the initial setup that happens when an object is created. So why do we need constructors? Constructors help us initialize object properties efficiently. Without constructors, we would need to assign values manually every time we create an object. This not only increase code repetition but also makes the program less organized. So constructors make our code cleaner, shorter, and more efficient by handling initialization in one place. Types of constructors. In Java, there are mainly three types of constructors: default constructor, parameterized constructor, and copy constructor. The default constructor does not take parameters. The parameterized constructor allows us to pass values, and the copy constructor, although not built in, can be created manually to copy values from another object. Default constructor. A default constructor is the constructor that does not take any parameters. It either assigns default values or simply performs basic initialization as shown in the code. When we create an object, the constructor is automatically called. If we do not define any constructor, Java provides a default one internally. This flowchart shows how object creation directly triggers the constructor. Parameterized constructor. A parameterized constructor allows us to pass values at the time of object creation. This helps us initialize objects with specific data right from the beginning. For example, instead of assigning a name later, we can directly pass it while creating the object. This makes the code more efficient and flexible. Constructor overloading. Constructor overloading means having multiple constructors in the same class with different parameters list. This allows us to create objects in different ways depending on the situation. For example, we can create an object with no data, partial data, or complete data using different constructors. Key rules of constructors. There are some important rules we should remember. Constructor must have the same name as the class. They do not have any return type. They are automatically called when an object is created and they can be overloaded but cannot be inherited. Constructor versus method. Constructors and methods may look similar, but they serve different purposes. A constructor is used to initialize an object and is called automatically, while a method is used to perform specific operations and must be called explicitly. Also, methods have return types, whereas constructors do not. So, real life analogy. To understand this concept better, think of a constructor like the birth of a person. When a person is born, basic details like identity are assigned automatically. Similarly, when an object is created, constructors initialize its properties. So, constructors ensure that every object start with proper initial values. So, from now, Shivam Singh will continue.
Now let's move to the second important concept of Java OOPs. Inheritance. Inheritance helps us reuse code and build relationship between classes. What is inheritance? Inheritance is a mechanism where one class acquires the properties and behavior of another class. This helps in reducing code duplication and improves efficiency. In simple words, it is similar to how children inherit characteristics from their parents. Now we see a basic syntax on inheritance. In Java, inheritance is implemented using the extend keywords. The class that inherits is called the child class, and the class being inherited from is called the parent class. The child class can use all the accessible methods and properties of the parent class. This diagram shows how the child class is derived from the parent class. Types of inheritance. There are mainly three types of inheritance in Java: single inheritance, multi level inheritance, and hierarchical inheritance. Java does not support multiple inheritance with classes to avoid ambiguity, but it can be achieved using interfaces. Now we see what is single inheritance. In single inheritance, one child class inherits from one parent class. This is the simplest and most commonly used form of inheritance. This diagram clearly shows one-to-one relationship. Now we see what is multi-level inheritance. In multi-level inheritance, a class inherits from another class which itself inherits from another class. This creates a chain-like structure where properties are passed down multiple levels. We can see the diagram here. Now we see what is hierarchical inheritance. In hierarchical inheritance, multiple child classes inherit from a single parent class. This allows different classes to share common features while having their own specific behavior. Here we can see the diagram of hierarchical inheritance. Now, in inheritance, we use method overriding. What is method overriding? Method overriding occurs when a child occurs provides its own implementation of a method already defined in the parent class. This allows us to change or customize the behavior of inherited methods. It is also an important concept used in achieving runtime polymorphism. We can see example on method overriding, and now we see real life analogy. Advantage of inheritance. Inheritance offers several advantages. It promotes code reuses, improves maintainability, and helps in organize a code in a structured way. It also supports advanced concepts like polymorphism. Now we see real life analogy. To understand this better, consider the example of vehicle. All vehicles share common features like speed and engine, but cars and bikes have their own unique functionality. So here vehicles act as a parent class while car and bikes act as a child class. This is the concept of inheritance. Now we uh, conclude that today we discussed two fundamental concepts of Java OOPS: constructors and inheritance. Constructors helps in initializing object efficiency and ensure that every object start with proper values. On the other hand, inheritance helps us reuse code, reduce duplication, and build meaningful relationship between classes. Together, these concepts make our program more organized, efficient, and scalable. Understanding these basics is very important because they found from the foundation from advanced topic in Java like polymorphism and abstraction. Thank you for your time and attention. I hope this presentation helped you understand this concept better. I would be happy to answer any questions if you have.